So the next thing we look at are non-unit circles of radius r. So for this, we're going to use a similar triangle argument. So this first one is going to be a unit circle. Angle theta. And this point is going to be r. We'll call it x naught, y naught. Then we have some other circle. We'll keep it centered on the origin though. But instead of a radius of 1, we have a radius of r. We're going to keep that same angle theta. We're still going to drop our nice pretty perpendicular there. And this point will be at xy. So by angle, these are similar triangles. They each have a 90 there. They each have angle theta. So since they're similar triangles, we know that we can use proportions. So for example, sine theta in this little guy is y naught over 1. We also know that the ratio of this leg, y naught, to the hypotenuse in the little triangle is the same as the leg to the hypotenuse in the big triangle. So we can also then say, by substitution, that sine theta on the big guy is equal to y over r. And you can make a similar argument for the cosine. Cosine theta on the little guy is our x naught over 1. By the fact that we have similar triangles, the ratio of the bottom leg there to the hypotenuse is the same as the bottom leg to the hypotenuse in the big triangle, and by substitution then cosine theta is x over r. And from there we could build all of our similar definitions. Tangent theta, ratio of sine to cosine, y over r divided by x over r is the same as multiplied by r over x. So notice the radius is irrelevant to the tangent. It's still just y over x. And their buddies then would just be the reciprocals. So cosecant theta is just the reciprocal of the sine, so that's r over y. Secant theta, reciprocal of the cosine, so r over x. And cotangent theta, reciprocal of tangent, so x over y. So we can use that to find some trig values of points that are on a circle that's not necessarily a nice, neat, pretty unit circle. So we're still centering on 0, 0. We'll make a quick sketch of that. Again, as you've seen from mine, they don't have to be works of art. So negative 5, 12, we're here in Q2. So here's the center of our circle. We'll drop our perpendicular there. So this is 5 units in the negative direction. So it has a length of 5, length of 12 up here. So 5 squared plus 12 squared equals r squared. So 25 plus $1.44 is r squared. So r squared is 169. So r is root 169 is 13 on the money. So then the sine of our angle theta, so this is theta here, y over the radius, so 12/13. Cosine of theta, x over the radius, negative 5/13. Tangent theta, sine over cosine. 12/13 instead of divided by negative 5/13, we'll think of it as times negative 13/5. So that is negative 12/5. And then their partners are, of course, again, just reciprocals. So the cosecant would be 13/12, just flip the sign. Secant theta, flip the cosine. Cotangent theta, flip the tangent. And there's our exact values. So even if they just give us a point on some other circle that's not necessarily the unit circle, we can still find values of the associated trig functions. Alright, so if you're trying the homework out of the book, this was section 6.2, I would try it 1 to 12, all 21 to 105, every other odd. There's a little bit in there about using your calculator to find decimal approximations. That one is really just hitting keys. If you have trouble with it, we'll go over that when you ask homework from this. Okay, if you have any questions, please feel free to get in touch with me. Otherwise, stay safe out there, and I will see you next time.